Hi, hello, welcome. So in this video, we'll solve a rearrange positive and negative values problem. Let's understand the problem statement first. There'll be given an array, so which is consists of both negative and positive values. So we need to rearrange these elements such that all the negative elements appear at one side and the positive elements appear at other side. So how do we solve this? So let's consider first solving the brute force. Then we'll see the simple and the best solution. As always, we'll always start solving the brute force solution and then we'll be uh, optimizing that for the best solution. So that's a good approach for any problem to solve. So when we see this problem, so what we can do is straight away we can do a sorting on this array. So when we do a sorting of this array, so all the negative elements will be end up in the starting, and all the positive elements will be um, positioned in the second half. So when we do a sorting, so this array will be like -9 and -6 and -1 and then 4, 5 and 10 and 20. So if you see here, all the negative values are starting and all the positive values comes after that. And if you see in a sample output, there is no order, doesn't matter actually. So whenever we order it, whatever the negative values comes starting or the positive values comes, the order doesn't matter. So we don't have to worry about that. But when we consider the time complexity of this problem is, of this solution is, time complexity of this solution is big O of n log n and space complexity is constant. So if you consider the big O of n log n, so this is not that good solution. So can we do a better than this solution? Yes, let's discuss that. So other simple solution would be by using temporary array, we'll create an array of size the same equal to the input array, and then whenever the positive values comes, we'll insert that particular array in the right side, and whenever the negative values comes, so we'll insert that values in the left side. So let's see with an example. So we'll create an array of size here input array. So this is a positive element which is 10. So that's the reason we'll be inserting at the rightmost index. And when we occur the -1, so which is the first index we need to insert, which is left side of the array, temporary array. And then when we increment to a next index, which is 20, again this is positive, we'll insert at end. And when we see the next element, which is 4, this is also an positive, so we'll insert at the right side. And when we see the next element, which is 5, this is also an positive, so we'll insert at the right corner. And when we see a negative value, which is 9, so we'll insert at the left side of this array. And then we'll increment to next element, and which is 6, we'll increment to the left side itself. When we see this, all the negative values are segregated at starting and all the positive values are segregated at last. So this is how we can solve it. So if we see the time complexity, so time complexity will be as we are iterating only once throughout the array. So that's the reason it will be big O of n. But when we see the space complexity will be big O of n because we are using the temporary array. So that's the reason. So the space complexity will be big O of n. Let's jump into the code and understand the logic. Now let's look at the code. So this is a method. So with extra space we are creating it. There will be an input array as a parameter and we need to return the whatever the temp array which we have created. So if you see here, we are keeping the negative index which starts from the left is nothing but the 0th index. And the positive index we are starting from the rightmost corner. So that will be a length -1 which will be the lastmost index. And then when here actually we are iterating throughout this an array by using for loop. To do that, so we are creating an I as an index and starting from the 0th index, and we are iterating throughout all the elements of an array. So that condition is If the index is less than array length, then we will be continue to iterate throughout this array, and for each iteration we are incrementing by 1. So this is all the condition for for loop. And for each iteration or for each element, what we are doing is we are having this condition. So the current element, which is array of I, the current index of this array, we're checking whether this element is negative or not. If it is negative, at this left side of this temporary variable, so we are keeping the current element, we are assigning this current element, and we are incrementing also the negative index just to move to a next index. And if it is a positive, meaning if it is greater than or equal to 0, means it is a positive. In that case, we are having the positive index and we are inserting at the rightmost of this temporary variable, which we call it as a rearranged array. We are assigning the current element, and also we are decrementing by 1. And finally, we are returning back this temporary variable. Like already we have discussed what is the time complexity and space complexity. But if you see here, so the space complexity is big O of n, because we are using the extra memory. So that's the reason big O of n. So is there any better way or better solution for better solution compared to the space complexity? So how do we achieve that? So let's see with the code. Let's see with the code and understand. Now let's understand. So in this solution, how do we solve without using extra space? Or like how do we solve by using an in-place swap? So let's consider for solving this problem, we need to have two pointers. Left as a pointer, which will be pointing to as the beginning of an array, and right as a pointer, which will point to an end of an array. So let's say the left will be pointing to starting of the array, and the right will be pointing to an end of an array. And this while loop will be like keep on it like this while loop will be keep on iterating till the left is less than right. And the first step, what we do is the left keep on moving towards the right till whenever it founds a negative value. If it is not finding any negative value, so it will stop iterating this loop. That's the first step. And the second step, the same thing it will happen for the right pointer till it finds a positive number. It will keep on moving towards left, and both the loops will have the condition left should be less than right, and both the conditions will have that. Once they found the values which need to be swapped, so left and right, meaning left, if it finds the positive value, it will stop. If the right finds the negative value, it stops. And then both the elements need to be swapped, because the left side should be always the negative values and the right side should always be in positive values. Whenever it finds, it will look for if it is left is less than right, and if that is the case, it does a swapping here. To do a swapping, the array of left, it will assign to a temp element, and array of right is assigned to an array of left, and then the temp value will be assigned to an array of right, and left will be incremented and right will be decremented, meaning the left will be moving towards the right and right will be moving towards the left. So let's see with this an example. So as I said, left will be pointing to an beginning of an array, and right will be pointing to an end of an array. So this is positive, the value. So that's the reason the left will be stopping here itself. This loop will be starting here itself. And the right also, it will not continue to do. It will also stop in the first itself. So both are eligible for swapping. So they do a swap. So once they do a swap, it will be like -6, -1, and 20, 4, and 5, and -9, and 10. And the left will be moved to a next element, and here the right will be moved to an before element. Again, this negative, because this left is negative, that's the reason it will move to an next element. So now the left element found an positive number, so that's the reason it will stop. And the right also it will stop because it has found the negative value. And then it will the both are perfect fit for swapping. Say they do a swap. So after doing a swapping, -6, -1, and -9, and 4, 5, and 20 and 10. So this will be the next thing. And when right will be moving to an 5, the right will be moved to 5, but 5 is positive, so it will not stop. It will come to 4. 4 is also positive. It will not stop. So what it does is it will say point to an -9. So the right value is also an same index, and the left pointer is also in the same index. So this condition will break the while because left should be less than right. That's the reason this whole for loop or the whole while loop will break. And when we compare this element, all the negative values are under left and all the positive elements are segregated in the right elements. So this we have achieved the expected output. So let's understand this what is the time complexity with this. As we are iterating only once throughout an array, so time complexity will be big O of n, and we are not using any extra space. We are using two variables as a pointers. So the time complexity will be constant time, constant space. Thank you for watching.